Hey math kids, today we're going to talk about the fundamental theorem of algebra, and what it says is if we have a polynomial and it has degree n, then there are n zeros. So what that essentially means, if our highest coefficient or our highest power of x, or the degree, is 10, then we'll have 10 zeros. If the highest power is 4, then we will only have 4 zeros. Now those can be real roots, those can be complex, they can be purely imaginary, and they can also repeat. But there will be a total of 10 or a total of 4 depending on the situation. Okay, now if we have negative 3 plus I, and we're given this polynomial, and we know that A is real, we want to find A. Okay, cool. So what we need to recognize is that complex zeros show up in conjugate pairs if the coefficients are real, which we know that they are. So what we need to do is the sum and product. So if we add these together, the sum is negative 6. If we multiply these together, we get 9 plus 1. When they're conjugates, you can just multiply like terms. Now that's only true with conjugates because conjugates make the I disappear in the middle. So I did negative 3 times negative 3 is 9. I times negative I would be negative I squared, which is just equal to 1. Negative 1 times negative 1 is 1. So the product is 10. Now we know that a factor is going to be x squared minus the sum. So in this case it's going to be plus 6x, and then we keep the same sign. So change the sign on the sum, keep the sign on the product. Now if we're looking at this and we're comparing, we want to try to make these happen. This needs to be multiplied by ax, and this needs to be multiplied by negative 3 to make this happen. Okay, now if we multiply this out, we get ax cubed minus 3x squared. Multiplying this, we get 6ax squared minus 18x, and then 10 times that would be 10ax minus 30. Okay. Alright, so now I'm just going to write common terms, combine like terms. 6a minus 3 and then this is going to be 10a minus 18 and then minus 30. Okay, now we just need to compare it to this one up here. And so a equals a, that's not helpful, but we can say 6a minus 3 is equal to 9. We can say 10a minus 18 is equal to a. Then negative 30 equal to negative 30 is not helpful. Okay, so we just add 3 to both sides. 6a equals 12, divide by 6, and a is equal to 2. And okay, and we want to find that linear factor, so that's really a 2x minus 3. and it wants us to find all the zeros. So we already have 2 of them right here, and so we just need to set this equal to 0, add 3, 2x is equal to 3, divide by 2, and x is equal to 3 halves. So there's 3 zeros. It was a third degree function, or third degree polynomial, and we found the 3 zeros, so that's how we know that we're done. Okay, let's do another example. Okay, so they give us ax cubed plus a plus 1 x squared plus 10x plus 15, and a is a real number. I lost my place, sorry. Okay, and one of the zeros is purely imaginary. It says find a and the 0 of the polynomial. Okay, so we're going to call the imaginary 0 is going to be bi. Okay. And so, because we have to have complex roots, we also have, we have to have conjugate pairs when we're doing this. And so, if we were to add these together, their sum is going to be 0. And if we multiply them together and get the product, we're going to get negative b squared I squared, which is just b squared. Okay, so when we're multiplying those together, we get x squared, and there's not going to be an x term because it would be like plus or minus 0x, and then plus b squared, and so it's just x squared plus b squared. Okay, and then we need to think, what do we need to multiply this by to make this term and this term? Well, we need to multiply this one by ax. And then to get 15, it's kind of crazy. So it needs to be 15 over b squared, because we need to kind of cancel the b squared because it doesn't show up here. And then we need to get the 15 into it. All right. And so we need to multiply this out. So ax cubed plus 15 over b squared x squared. And then this times this is going to be ab squared x. And then this times this is just going to be 15, because the b squareds would cancel. Now we need to compare the coefficients. So a equals a doesn't really help. A plus 1 is equal to 15 over b squared. Might be helpful. And then 10 is equal to ab squared, and then 15 equals 15 is not helpful. Okay. Now we just need to solve for 1, and let's see, I'm trying to think if there's something that, other than substitution, Maybe not. Okay, so I'm just going to subtract 1 over here. So I have a equals 15 over b squared minus 1. I'm going to plug all that in for this a. So I get 10 is equal to 15 over b squared minus 1 b squared. Distribute that to both of these. That gives me 15 because the b squares would cancel, minus b squared. Subtract 15, so that's negative 5 equals negative b squared. The negatives on both sides would just cancel. And then I can square root both sides, and so b is equal to plus or minus the square root of 5. Okay. Now I can plug that in here. 10 is equal to a times square root of 5 squared. It doesn't matter if it was positive or negative because it's going to go away when we square it. Okay, so that's just 5. So 10 is equal to 5a, and so a is equal to 2. Okay, and when we plug in these values to this green one right here, we're going to get 2x. When we plug in the square root of 5 and we square it, it's really just like a 5. So 15 divided by 5 is 3. Okay, so we have the linear factor right here, and we need to find all of the other factors, or the zeros. Yeah, we want to find the zeros. So this one, we can just, we almost have everything right here. So all this is going to help us. I'm just running out of room. You'll go this way. Okay. So we have bi, we have negative bi, and then we have 2x plus 3 is equal to 0. Is going to help us find all those zeros. So b is plus or minus the square root of 5. So it's just going to be square root of 5 with an I, negative I, square root of 5. And then when we solve this, negative 3, 2x equals negative 3, divide by 2, divide by 2, and we get negative 3 halves. So those are the 3 zeros. It was a third degree polynomial, so we know that's all we needed. If you have any additional questions, come to Math Lab. Until then, calculate.